Okay, so we started having a look at differentiation, and we looked at differentiating different values. We looked at differentiating trig values, we looked at differentiating exponential values and log values. We're going to move on to the part of differentiation now, which we will probably use the most of, and there's a few different things that you need to know. And they're broken up into three parts. So we'll have a look here. Composite functions. We've got the product of two functions and the division or the quotient of two functions. Okay, so we're looking now at, when we say composite, it's all about, the way I like to think about it is a little bit like an onion. You've got like a function within a function. So in here, the function here, we've got two functions, one inside each other. The inside one is that 1 plus the 3x. And the one that's outside of that is the square root. So we've got like an inside function and then one inside it again. The product of two functions is when we're timesing two things together. So here we've got x times by sine of 2x. So we've got two things which are multiplied together there, like so. And then the last one is the quotient, so where we've got ln x divided by x. And there's some rules that you'll need to know for this. So the first one we're going to have a look at is called the chain rule. Okay, and this is where we've got like a function inside a function. Now, when you've got a function inside a function, you start from the kind of the most outer layer, and then you differentiate all the way down and in. Okay, so let's have a look at this one here. So get this one down as example 1 for this. So with this one's only got two layers. The outer layer is this to the power of 5, okay? And then the inner layer is this part here, the 3x to the 4 plus x. Okay, so you've got this outer layer, which is to the power of 5, and you've got this inner layer, which is 3x to the 4 plus x. That's what we've got. Okay, so when we do this, we need to differentiate the outermost layer using what we know, first of all, and then differentiate the innermost layer and multiply by that. And this is what's called the chain rule. So it's from this part here. So dy by dx is dy by du times by du by dx. Now, don't worry too much about that. The best way to think about it is about those layers and kind of starting at the outermost layer and working our way in. So here we've got y is equal to bracket 3x to the power of 4 plus x all to the power of 5. So the first thing I've got to do is to differentiate that power of 5. So when I'm differentiating this one, it's going to be dy by dx is equal to, now if this here was just x to the 5, the way I do this is I times by the 5 and take away one of the powers. Okay, so with this one here, it's going to be times by 5, and then you take away the power, but that middle part stays the same. So it's going to be 3x to the 4 plus x all to the 4 there. So I've differentiated outside of that bracket. Once you've done that, you differentiate what's inside the bracket and then multiply by this. So times by the differential of what's inside that bracket, which is this part here. So if I times by that, it's going to be 12x to the 3 plus 1. Brilliant. And that's it. So you can simplify this if you want to. So dy by dx is equal to 5 times by 12x to the 3 plus 1 times by 3x to the 4 plus x all to the 4. So that's the differential of this one here. So we've differentiated outside, and then we differentiate inside and multiply it. That's why it's called the chain rule. It's like a chain going down. So let's have a look. There's that one there. They wrote it here. Doesn't matter what order those products are in. Okay, so we've got some more here. So I'm just going to talk about the layers first of all. I'm going to do all of these. So the first layer of this one is this 3, and then inside that layer is that x squared plus 1. This one here at the outside layer is the 3, and inside that layer is the y ln x. This one here, now the layer in this one here is different. The layer of this first one is the e to the power of e to the e to the power of x squared plus 1. So the outside layer on that one is the e. The outside layer on this one is the 2, and the outside layer on this one is that ln. Okay, so it's all about recognizing what's an outside layer and then an inside layer. Sometimes you even get 3 or 4 layers, so you've got like an outside layer, then an inside layer, then an inside layer again, and then an inside layer again. But for now, we're just going to deal with 2. So the way that we do this is we differentiate by the outside layer, and then you differentiate the inside layer and multiply by it. So the outside layer, if that was just x to the 3, it's going to be this, isn't it? So it's going to be, you times by the 3 and take away 1 from the power, so it's going to be 3 bracket x squared plus 1 all to the power of 2. And then we differentiate the inside layer and times by it. So this part here differentiates to 2x. So it's going to be times by 2x like so. Brilliant. So this next one here is very similar. So the outside layer is that 3. So it's going to be 3 bracket ln of x all to the 2. And then if I differentiate inside that layer and multiply by it, well, the differential of ln x is just going to be equal to 1 over x. So I do that one there. And obviously you'd simplify these. I'm not simplifying them now, but you could simplify them if you wanted to. So this one would be 6x bracket x squared plus 1 all squared. This is equal to 3 over x times by ln of x all squared. Now this one here, if I differentiate e to the x, is just e to the x. So the outside layer is that e to x. So if I differentiate the outside layer, it's just going to stay the same, e to the x squared plus x. And then I differentiate that inside layer and multiply by it. Well, this one here is going to be 2x plus 1. So I times by that there. Okay. Probably would have brackets around this. This next one here is going to be 2 to the 2x plus 1. 2 take away 1 is going to be 1, so I'm just going to leave it like that. And then times by 2 to the x ln of 2. That's how we differentiate 2 to the x. It's not the same as e to the x. Now the last one, so this one here, if I differentiate outside that function, ln is 1 over what's inside it. So it's going to be 1 over sine of x times by differentiate inside of that, which is the sine x, which goes to sine differentiates to cos of x. So this would be equal to cos over sine, which is equal to cot of x. Now I can simplify all of these. I probably should do really. So this one here would be equal to 2 to the x plus 1 times by e to the x squared plus x. This one here is going to be 2 ln 2 times by 2 to the x times by 2 to the x plus 1. Brilliant. Super. Okay. Can I just have a show of hands? Is everybody all right with that?
Sir, do you know for the last one?
Okay, so the question was, why is it 1 over sine x when it's just 1 over x? Well, the outside layer, whatever's inside that layer stays the same, okay? It doesn't change. So here, this one here, if you think about this first one, you bring the power down and then take away, you times by the power and then take away 1 from it. So 3 times by the 3, but that inside part stays the same. Same with this one, so that inside part stays as ln x. Here, the inside part stays the same, and exactly the same with this one. So when you're dealing with ln of sine x, the inside part of it needs to stay the same. And the ln, you're right in saying ln of x is 1 over x, but ln of sine x is going to be 1 over sine x. The outer layer says just 1 over that part. Does that make sense? Yeah. Okay. So there's our first one. We've done all of those. So there's some more practice here. We definitely do need to start thinking about these. Okay. So let's get rid of this. So we've already started looking at this, haven't we? We've already started looking at sine of 5x, and we know that sine of 5x differentiates to 5 cos 5x. However, we can start thinking about the reason why this is using the chain rule. So my outer layer here is this sine x, and the inner layer is going to be this 5x. Okay? If I differentiate sine x, that's going to be equal to cos of the 5x. And then I times by the differential of inside of that. Well, if I differentiate 5x, it's just going to be equal to 5, like so. Now, with this one here, we need to think about how we need to write it first. So this one, we write it as sine of x all squared. And your outer layer in this one is that squared part. Okay? If I differentiate the outer layer first, it's going to be 2 sine of x. Well, I'm going to take away 1. I could do this like that. Well, I'm not going to do that because I know anything to the power of 1 is just the same. But don't forget, I've got to differentiate inside that layer. Now, inside the layer is that sine x there. So if I differentiate sine x, that's equal to cos x. This one here, I'm going to have to change again. So it's going to be x plus 1 all to the power of half. Outside, the outside layer is going to be equal to this half here. So it's going to be half of x plus 1 to the power of minus a half take away 1, times by the inside layer. Well, if I differentiate x plus 1, that's just going to be equal to 1. This one here is a little bit trickier again. So here we've actually got 3. Now, I told you there was 3, didn't I? So I told you that sometimes there were 3. So we've got 3 things that we need to, for 3 layers. So let's just talk about what those layers are. We've got, let's write it like this first. Cos of 2x all to the power of 3. Said 3, wrote 2, all to the power of 3. So our 3 layers are the 3, which I'm going to have to deal with first. Then I'm going to have to deal with the second layer, which is going to be the cos. And then my innermost layer is going to be this 2x here. So I've got to deal with all of these, differentiating and times it as I go through. So if I differentiate the 3, keeping everything inside the same, I end up with 3 times by cos of 2x all squared. So that's the outermost layer, keeping the things inside that the same. The next layer I'm going to need to do is that cos. So I'm going to have to differentiate cos and keep that inside layer the same. So cos, thinking about this, sine, cos, minus cos, sine, cos, minus sine, minus cos, differentiating is that way. So cos is going to differentiate to minus sine. So this is going to be equal to times by minus sine of 2x. I'll put a square bracket around that so you know it's times by all of that. And then my last layer is going to be that 2x when it comes back. There you go. Put those brackets back. And the last layer is that 2x. So times by, if I differentiate 2x, that's just going to be 2. So times by 2. And again, you could simplify this one, and you probably would. So 3 times 2 is 6. The minus in front of there is going to be, because it's going to be the minus from that. And then it's going to be sine of 2x cos squared of 2x. Minus 6 sine cos, minus 6 sine 2x cos squared 2x. Brilliant. This one here, again, I've got 2 layers. So I'm going to differentiate this part first. Then my second layer is going to be this part here. And then the third layer is going to be that x, but x just differentiates to 1. So it's going to be, if I differentiate e to the x, it just stays as e to the x. With the e to the x, e to the x. And if I differentiate the e to the x inside of that, it's going to be e to the x like so. Brilliant. So it's all about thinking about those layers. The outside layer first, differentiate, keep whatever's inside. Then differentiate inside it, then multiply by that. Then differentiate what's inside of that and multiply by that. And this is where the chain comes from there. Brilliant. So we've had a go at those two. Have a little go at these two yourself. Have a little go at these two yourself. Okay, I can still see that some people are starting to finish. So let's have a go at these then. So we've got two layers on this first one. The outermost layer is this lnx, and the inner layer is going to be this part here. So I'm differentiating my outer layer. If I differentiate lnx, that's going to be 1 over x. If I differentiate ln of all of that, it's going to be 1 over all of that. So 1 over x squared plus 3x plus 5 times by the differential of inside that times by it. So it's going to be 2x plus 3. So the differential of this, dy by dx, is equal to 2x plus 3 all over x squared plus 3x plus 5. Brilliant. This next one here, we've got our two layers. Now we're going to have to change that square root first. We're going to have to write it as y is equal to 5x squared plus 1 all to the power of a half. So if I'm differentiating this one, it's going to be dy by dx is equal to, the outermost layer is that half, so it's going to be a half of 5x squared plus 1 all to the power of minus a half. And then I differentiate inside that and multiply by it. So times by 10x, well that's just times by 10x, isn't it? So this is equal to, that 10x is going to cancel there, but only because it's not got a power on it, so that will cancel there to become 5. So I end up with 5x times by 5x squared plus 1 all to the power of a minus a half. Now it says find dy by dx at 4, 9. So the only thing I really need to know there is the 4. So I'm going to sub that in. So dy by dx is equal to 5 times by 4 times by 5 times by 4 to the power of 2 plus 1 all to the power of minus a half. Let's get that up. So it's going to be 5 times by 4 times by 5 times by 4 all squared plus 1 all to the power of negative 1 over 2. Check that. 20 over 9. Super. Super. Let's just check that. Brilliant. So there's your answers. Pop your hands up if you're happy with all those. I quite like the chain rule. I think it's one of my. I think I do quite like these. I think it's kind of nice to see that logical approach to it, and you'll start to see these more and more. Okay. All right. So we've had a look at the chain rule. So we're going to look now at differentiating things which are in terms of y. Now, to be honest, it's exactly the same. It's no different. It's just that you need to change things around, okay? So this is important. This is what we need to know. dy by dx is equal to 1 over dx by dy. Now, it's a little bit like a fraction. You can think about it like that. So obviously, if you're thinking about dividing by a fraction, it's going to be 1 over the reciprocal of that fraction. So if I want to find dy by dx of this one, I thought this one was a little bit later, but it's okay. If I want to find dy by dx of this one, then I'm going to differentiate this with respect to y now. So it's going to be dx by dy is equal to 4y plus 1. So I've differentiated with respect to y. And then if I want to find dy by dx, it's going to be the 1 over that. So it's going to be dy by dx is equal to 1 over 4y plus 1. Nice and straightforward. Next one here. Again, I just do it exactly the same way. I'm going to have to use the chain rule with this one. So dx by dy is equal to 3 times by 1 plus 2y, all to the power of 2. So I've differentiated the outermost layer first, which is that 3. Then I need to differentiate inside that and times by it, which is going to be, if I differentiate by that, it's going to be times by, well, if I differentiate that with respect to y, it's just going to be equal to 2, so times by the 2 there. So this is going to be dx by dy is equal to 6 times by 1 plus 2y all squared. And if I want to find the gradient of the line when y is equal to 1, then I need to sub in 1. So dx by dy is equal to 6 times by 1 plus 2 times by 1 all squared. So that's going to be, let's just do it. Uh, 6 times by 1 plus 2 times 1, close bracket, all squared, is equal to dy by dx is equal to, dx by dy is equal to 54. So dy by dx is equal to 1 over 54. Cool. Super. Let's just check those. Brilliant. Put your hands up if you're happy with that. Super. Okay. So we're going to have a look at a new rule, which is called the product rule. So the first one was the chain rule, where you've got kind of things which are inside each layers, and you've got kind of the layers going down. This is different now. This is the product rule, and this is when you've got two things which are multiplied by each other. So you notice I'm not going to do this one just yet, but here we've got two things which are multiplied by each other, which is the x squared times by sine of x. So when you are doing these ones, you've got to use this formula here. So dy by dx is equal to u dv by dx plus v du by dx. This is the bit that's important. And I'll show you how to do that with this one. I think this is probably one of the easier ones to do, to be honest. If you can spot that it's the product rule. You've got to know the difference between them, though. So the best way to do this, and this becomes really easy when you see how to do it, is you label each of the ones or each of your products as U and V. Okay, so we're going to say that U is equal to X squared and V is equal to sine of X. We've got two things multiplied by each other. And then we're going to differentiate both of these separately. So du by dv, sorry, du by dx, we're differentiating with respect to x, is equal to 2x. dv by dx is equal to cos of x. We know that differentiates to cos of x. And then we just sub it into the formula, which is the product rule, which is dy by dx is equal to u dv by dx plus v du by dx, which is equal to, now u is x squared. It's always kind of a cross usually like that. Multiply these. If you want to do a quick way, you don't need to write it out every time, but it's nice to do it at first. So it's u dv by dx, which is x squared cos of x plus v du by dx. So it's going to be, I'll do the du by dx times by v first, so we've got the 2x in the front. So it's going to be 2x times by sine of x, and there we go. That there is an example of the product rule. So here, determine the coordinates of the turning point. Well, we know straight away turning point is going to be when dy by dx is equal to 0. We know that. So, first thing I'm going to do is to write down what v and u are. I can see that it's two things multiplied by each other, x times by e to the 2x. So u is equal to x, v is equal to e to the 2x. If I differentiate u, du by dx is equal to 1. If I differentiate dv by dx, that's equal to, well, I'm going to use the chain rule in this, times by the, differentiate the e, and then times by the differential of that. So e differentiated is just e, times by a differential of 2 to the x, which is going to be 2e to the 2x, like so. And then dy by dx is equal to u dv by dx plus v du by dx, which is equal to u dv by dx, which is going to be these two times together, so u and dv. I'm just going to do it straight away. So it's 2x e to the 2x. I'll just put that 2 in front at the beginning. Plus v times by du, which is just going to be 1 times by e to the 2x, so e to the 2x. Now remember, we're trying to find the turning point here. So usually what we do is we factorize out that e to the 2x. So dy by dx is equal to e to the 2x times by 2x plus 1. Now remember, if I want the stationary point of this, then I know that dy by dx is equal to 0. So I'm going to say that 0 is equal to e to the 2x times by 2x plus 1. Anything equal to 0, either the first thing's going to be equal to 0 or the second thing's going to be equal to 0. So I'm going to say that e to the 2x must be equal to 0 or 2x plus 1 is equal to 0. So in which case, I'm going to end up with 2x is equal to ln of 0, which will be 1, but we'll talk about that in a second. Or 2x is equal to minus 1, so x is equal to minus 1 over 2. ln of 0, we do know that. ln of 0, just check it. ln ln of 0, I done that right, just check. Sorry, ln of 1 would be equal to 0, wouldn't it? Ln of 0 goes off to infinity, doesn't it? Checking this in my head. Yeah, I think that's right. Yeah. We can't have this one here. Was right. So we can't have this one here on the left. Good job, I checked that. So we still haven't finished though, because we do need the y coordinate of this, and I find the y coordinate by subbing that x is equal to half back into y is equal to this. So, because it's the coordinates that I want. So y is equal to minus a half times by e to the a half times by minus a half. Let's put that in there. So open bracket, minus 1 over 2, close the bracket, alpha e to the power of 2 times by minus 1 over 2, close that bracket, is equal to y is equal to minus 1 over 2e. Brilliant. Is that right? Stop doing that. Brilliant. Super, yeah. There's both your answers. Super. All right, so we've got some more questions here. So this is an example of using the product and the chain rule, okay? So we've got the product where we multiply two things together, and then we've got the chain rule, which is where we've got the layers inside. So let's have a go at this one here at the top then. So the first thing I need to do is to write down what V and U are. Write down, you always deal with kind of the product rule first, and then you differentiate inside there. So U in this first one is going to be equal to e to the 4x. V in this one is going to be equal to sine squared of 3x. Now, I'd probably write this one as sine of 3x all squared. There's actually 3 layers in that. So if I differentiate the u, du by dx is equal to 4e to the 4x. If I differentiate this one, it's going to be dv by dx. Well, the outermost layer is that 2. Then I've got the sine, then I've got the 3x. So it's going to be 2 sine of 3x times by, so that's the 2 first. The sine of x is going to times to be cos of 3x, like so, times by the innermost layer, which is that 3x, which is going to be 3. So this one here is 6 sine of 3x cos of 3x. Not finished yet. Remember, you need to sub it in. dy by dx is equal to u dv by dx plus v du by dx, which is equal to, now u is equal to this e to the 4, so e to the 4x times by v, which is this horrible big one down here. Let's just move it over. I'm going to just do it all in one, so we don't have to write it out a few times. So it's going to be 6 times by cos times by, sorry, times by sine times by cos. So I'm going to put the 6 there. 6 times by sine of 3x times by cos of 3x. So that's that u dv. Plus v du. Now v is the sine squared 3x times by du, which is that 4e to the x. So it's going to be 4e to the 4x times by sine squared on 3x. Now they want to take the sine and the e to the 4 out as a common factor, don't they? So dy by dx is equal to, let's take out, now I'm surprised they haven't taken out a 2 as a common factor there as well, but they haven't, so let's take the e to the 4 out. Let's take a sine of 3x out. So I'm left with, open bracket, 6 cos of 3x plus 4 sine of 3x. Let's just check those. 6 and 4, yeah, good. Brilliant. So that's the first one. Nice and straightforward, just doing all the different parts here. This next one here, let's give myself a bit of room there. So, we've got here u, which is the x squared, u, which is x squared, v, which is equal to, now I'm going to write it as 3x minus 1 all to the power of a half. So du by dx is equal to 2x, differentiating the u. dv by dx is equal to a half times by 3x minus 1 to the minus a half, so that's the outer layer, times by the inner layer, which is going to be equal to the 3, which gives me 3 over 2 times by 3x minus 1 all to the minus a half there, like so. Remember, then we're going to sub this into dy by dx is equal to u dv by dx plus v du by dx, which is equal to u, which is the x squared, times by dv by dx, which is going to be this part here. So it's going to be 3 over 2 x squared times by 3x minus 1 all to the minus a half, plus the v, which is this part here, times by du, so it's going to be 2x times by 3x minus 1 all to the power of a positive half. Now you can probably take out a common factor, take out a common factor of x. I'm going to leave it like that for now. I haven't asked me to do anything else, so that's fine. I should have, in fact, I've made a tiny mistake here, which means, because this is, this actually isn't dy by dx, it's f dash of x, isn't it? Because we're doing it in terms of function. Brilliant. Just check that. They've simplified it. So maybe I will do that just to take out that, just to take out the half from the other side here. So what they've done here, let me show you. They haven't asked you to do this, but they've done it here, so I might as well show you what they've done. They've taken out the minus a half from both sides, and if you take out a minus a half from both sides, it means that this is going to become 1. So I'm going to take out here, just check. They've taken out Again, you don't really need to do this. They've taken out a half times by 3x minus 1 all to the power of a minus half. If you take out the half from the first one, half x it should be, shouldn't it? If I take out a half x from the first one, I'm going to be left with 3x because I've taken out the minus a half. If I take an x out of the 2x, I'm just left with 2. If I take a half out, I'm actually going to have to double that, which is going to be equal to plus 4 times by, well, if I take out a minus a half from this, I need to add a minus a half here. So it's actually, this is going to go to 3x minus 1 there, like so. This is trickier. So this is going to be a half x times by 3x minus 1 all to the power of a minus a half times by, well, let's expand this out. 3x plus 12x is going to be equal to 15x. And then the 4 times by the minus 1 is minus a 4. So the last little stage here is going to be equal to f dash of x is equal to, right, that 2's on the bottom, that half's on the bottom, the x is on the top, so it's going to be x times by 15x minus 4 all over 2 root 3x minus 1. Brilliant. Check that. Yeah, there you go. Super. It is tricky, that. Okay, have a little go at those to yourself. Have a little go at those to yourself. Pop your hand up if you're finished. I'll start going through them. So I'm just going to give you a little hint for this bottom one if you're not sure where to start. And with the bottom one, the best way to write this is to go dy by dx is equal to 1 over 6 x to the minus 1 times by x to the minus 1 to the power of a negative a half, and start from there. You might be tempted to use the quotient rule on that one. I think I might have been, but you'd use kind of the product rule and the chain rule with inside the quotient rule. But you can start just like that. Pop your hand up if you've done the first one. So I'm going to go through that first one then. Okay, so here we have u is equal to x squared, v is equal to ln of 3x. du by dx is equal to 2x. dv by dx is equal to, well, what do we say that was? ln 1 over 3x differentiates to, well, it's 3, ln 3. I would have done what you said before and done 1 over 3x, but it's not. It's just 1 over x, this. Okay? So then we're going to use the product rule. Which is going to be u dv by dx plus v du by dx, which is equal to u dv by dx, which is equal to x squared times by 1 over x, plus v du by dx, which is going to be the 2u ln of 3x, which just leaves us with x dy by dx is equal to x plus 2x ln of 3x there, like so. Super. So they've said this one's quite hard. I don't think it's too bad, as long as you know where that starting point is. Maybe I would have struggled with that. So u is equal to 1 over 6 x to the minus 1. V is equal to x minus 1 all to the power of minus a half. du by dx is equal to, right, bring that minus 1 down, take away 1 from the power, so it's going to be minus 1 over 6 x to the minus 2. This one here, dv by dx is equal to minus a half times by x minus 1. Take away 1 from the power, which is going to be minus 3 over 2, times by the differential of inside of that, which is just going to be 1, so it stays like that. So, let's write down what these are now. So dy by dx is equal to u dv by dx plus v du by dx, which is equal to u, which is 1 over 6x to the minus 1, times by dv by dx, which is this minus a half, times by x minus 1, all to the power of minus 3 over 2, plus, oops, that should be d2y by dx squared, sorry, v du by dx, which is the x minus 1 to the minus a half, times by minus 1 over 6x to the minus 2. Let's now simplify this. So, minus 1 over 12 x to the minus 1 times by x minus 1 all to the power of minus 3 over 2 plus minus 1 over 6x to the minus 2 times by x to the minus 1 all to the power of negative a half. What can I take out of there to help me? If I take out a negative a half, that becomes squared, so maybe I'll do that. can take out the... I can take out an x squared as well, maybe. Or take out an x to the minus 1. So let's take out that minus. Let's take out minus 12. So minus 12. Let's take out that x to the minus 2. Let's take that out. And let's take out an x minus 1 to the power of minus a half. We'll deal with all of that later. Okay? But what I need to deal with now is what all of this becomes. So if I take out there, the minus 12 is fine. If I take out a minus 2, I'm going to need an extra x there, aren't I? So it's going to be x bracket x minus 1 to the power of minus 2 minus 2, just like so, just minus 2. Don't know if that's actually helped me. So they've taken out the minus 3 over 2. That's probably what I should have done. Okay. Let's go back there in a second. So, I mean, if you're doing this question and you're asking to go forward, you don't really need to do this at last part if you know what the coordinates are, but we're going to do it anyway just because they have. So I'm going to take out that minus x minus 1 to the power of minus 3 over 2, which would leave me with, if I take out the minus 12 minus x to the power of minus 2 and the x minus 1 to the power of minus 3 over 2, I'm just going to be left with x for this one. Minus, well, it's going to be, what do I need to times that by? It's going to be the 2, because I need to double that, don't I? So if that's going to be, if I take out a 12 from that, it's going to need to be double this. So it's going to be 2 times by x minus 1 all to the power of 1. So if I take that out, it's going to be to the power of 1. Yeah, I'm getting there now. So, let's just simplify this. The top is going to be x minus 2x plus 2. So x minus 2x is going to be minus 1. Plus 2 is going to be 2x plus, sorry, 2x minus 3. So the top's going to be 2. It's going to be minus all of that, isn't it? So it's going to be, let's just deal with this first. I need to be careful here. So I've taken out a minus from this, so it needs to be positive too. So it's going to be, let's deal with all of this at the bottom. So it's going to be minus there all over 12x squared x minus 1 to the power of 3 over 2. And this here is going to be 3x minus 2. So that's minus all of that, which is just going to be equal to 2 minus 3x all over 12x squared times by x minus 1 to the power of 3 over 2. Brilliant, there we go. Woof. Just check that. Yeah, good. All right, so we'll finish that up there. We'll look at the quotient rule next time. We'll continue on.